All right, so let's reinforce the rules that we've learned about exponents by finding equivalent expressions. And so all we have to do is to basically simplify the expression that they give you at the top and then find which of these expressions are equivalent. So if we start with 10 times 10 to the fourth, we know that the rule is when they have the same base, you can add the exponents. This is really a 1 here. So that's really 10 to the 1 plus 4, which is 10 to the fifth power. So I'm looking for 10 to the fifth power, which is this one here. This is obviously wrong. Just confirming that the other ones are also wrong. So your only answer is the fourth option. So for this one, we're doing division with the same base, so you can again subtract. So this time you can subtract the exponents. So that's 2 to the 36 minus 4, which is 2 to the 32nd power. So I'm looking for 2 to the 32nd, which is this one here. So that one, and this one are also wrong, obviously wrong. So the second option is the only one that's equivalent. So 7 to the third times 7 to the seventh is going to be, again, add the exponents because the bases are the same. So 3 plus 7 gives me 10, so 7 to the 10th power. And so this is the only one that is correct. That's wrong, that's wrong. That's 1 over 7 to the 10th, which is still wrong. So the first option is the only equivalent option. 7 to the 6th times 7 to the 1st is going to be 7 to the 6th plus 1, because again, remember, when there's no exponent, there's really a 1 there. So that's 7 to the 7th power. So this is the only correct option. That's wrong, and that's wrong. So the first option is correct. So now we're dividing powers that have different bases. So if that's the case, then I can just divide the bases, 12 divided by 6, and keep the exponent, which is going to be 4. 12 divided by 6 is 2 to the 4th power. So 2 to the 4th power is what I'm looking for. That's upside down. That's missing a 4. Let's see. So these two, which one is correct? Well, this is again subtracting. So that's 2 to the 8 minus 2, which is 2 to the 6. And that's not what I'm looking for. That's wrong. So this is 2 to the 9 minus 5, which is 2 to the 4th. And so this one is the correct option. So our second option is correct. So 7 to the 24th over 7 is 7 to the 24 minus 1. And again, missing 1 is 7 to the 23rd. And so I'm looking for it. That's obviously right. That's wrong. That's wrong. Let's confirm that this is also wrong. That's really 7 to the 4 plus 6, which is 7 to the 10th. And so that's also wrong. So we're confirming that our fourth option is the only correct option. Same thing here. We have 4 to the 6 times 10 to the 6, same exponent. So that means we're doing 4 times 10, and we're raising that to the 6th power. 4 times 10 is 40 to the 6th power. So that's wrong, that's wrong, that's wrong. 40 to the 6 times 1 is this one, because you have power to a power. So that's really 6 times 1, and 6 times 1 is 6. So it's 40 to the 6th power. So this is the only correct option, 40 to the 6th power. So now we have 4 to the multiplying 7 times 1. So 7 times 1 gives me 4 to the 7th. And so I'm looking for 4 to the 7th. Well, this is obviously wrong. That's obviously wrong. So let's see, between these two, this is really going to be, because I have the same base and the same exponent, I have options. But since I want to get 4 in the base, I should probably multiply 2 by 2 and keep the 7, which is 4 to the 7th. So this is right. Check this one. Same base, different exponents. So that means I have to add the exponents. So that's 2 plus 4. That's 4 to the 6th. So that means this one is wrong. So the only correct option is the first one. Four to the first plus 5 is 4 to the 6th. So that's wrong. 4 times 1 is 4. That's wrong. 4 times 2 is 8. That's wrong. These two, 2 times 2, would give me 4 to the 6th power. So this one is correct. The fourth option is right. Seven to the 1 plus 4. Missing 1. 7 to the 5th. That's obviously wrong. 5 times 1 is 5, so this is 7 to the 5th. So that's correct. 2 times 3 is 6. That's 7 to the 6th. That's wrong. 3 times 1 is 3. That's 7 to the 3rd. So that's also wrong. So the only correct option is the second option. 9 to the 3rd times 4 to the 3rd. Same exponent, so I multiply 9 by 4 and keep that to the 3rd power, which is 36 to the 3rd power. And so that's wrong. 36 to the 9th is also wrong. 36 to the 6th is wrong. So the only correct option is the last one, 36 to the 3rd. It's very important that you check all of your options to make sure that you aren't missing any. 12 to the 3rd times 12 to the 4th is going to be, add the exponents, 12 to the 3 plus 4 is 12 to the 7th. And so I'm looking for 12 to the 7th. That's wrong. That's wrong. That's upside down. So this should be the only one that's right. 7 times 1 is 7. So this one is correct. The fourth option is the only correct option. So again, we have division with the same bases. So that's going to be 4 to the 15 minus 5, which is 4 to the 10th. And so looking for 4 to the 10th, this is wrong. 2 times 1 is only 2. So this might be right. This is definitely wrong. And this one is definitely wrong. So let's confirm, because I have the same exponents, I can just do 8 divided by 2 and keep the exponent. So that's 4 to the 10th power, and that's what I was looking for. And so this is the only correct option. So 6 to the 2nd over 6 is 6 to the 2 minus 1, which is 6 to the 1st power, which we know is 6. And so that's wrong, this is right, that's wrong, and that's wrong. The second option is the only equivalent expression. 8 to the 3rd times 8 to the 5th is 8 to the 3 plus 5, which is 8 to the 8th power. So this is upside down. That's definitely wrong. Maybe this is right, but this is really 8 to the 8 minus 1, because you're dividing with the same base and different exponents, which is 8 to the 7th. That's not right. And so this one is the same exponent, so I multiply the bases, so 2 times 4, and keep the exponent, which is 8 to the 8th power. So that's what I'm looking for. So the first option was the only correct option in this case. 3 to the 6th times 3 to the 4th is 3 to the 6th plus 4, which is 3 to the 10th. I'm looking for 3 to the 10th. That's correct. This is upside down. This is way off. So this one maybe. So this is 3 to the 5 times 2, which is 3 to the 10th, which is what I was looking for. So that's correct. So that means that these two are the correct options. 7 to the 4th times 5 to the 4th is keeping the exponents and multiplying the bases. And so that's going to be 35 to the 4th power. Looking for 35 to the 4th power. This one's correct. That one's definitely wrong. The third option is upside down. The fourth option is wrong. And so the first option was the only correct option. So as you can see, even in a challenge zone, all the questions are the same. So there's no need to go through the rest of this. It's not difficult. You just have to follow the rules. If you need to refer to the rules, then just look them up. They're available on the agenda. And if you have any issues, reach out. Let's get this done.